In this tutorial, we are going to see how to create a histogram in Minitab. Let's start with this scenario. A bank manager wants to have a better understanding of the turnaround time to approve a credit card application. He wants to have a summary information about the approval time. We have historical data to analyze. Let's have a look at it. Column C1 contains the branch where the application was processed. Column C2 contains information about the type of credit card. Column C3 contains the time it took to approve the application in days. Would it be enough to calculate an arithmetic average of the approval time? Unfortunately, we know that the average is not always as informative as we might hope because it can be influenced by extreme values or outliers. So what kind of information shall we consider? When we want to describe numerical data, it's good to know how the data varies, what range of values occur the most frequently, and if there are any outliers. So when we want to analyze numerical data, we can use a histogram to answer those questions. A histogram is similar to a bar chart, but it groups numbers into ranges. The x-axis represents the scale of the data, divided into intervals that are called bins. The y-axis shows the frequency. Each bar represents the number of times an observation falls into the interval represented in the x-axis. For example, this bar is 11 units high because within the dataset there are 11 applications that have been approved between 8 and 10 days. We can easily see as well that there is data far from the other data points. These data points are called outliers. The histogram can be described by its shape, center, and spread. Let's do it in Minitab. The variable that we are going to analyze is the data in column C3, approval time. We click on Graph, Histogram. The first step is to define the type of histogram we want to display. We keep the default option already selected and we click OK. The second step is to specify the column we want to plot. So we click on Approval Time, select OK. The histogram is showing the frequency distribution of the approval time in days, and it can be described by its shape, center, and spread. In regards to the shape, sometimes it's convenient to change the scale of the x-axis to make the shape appear more evident. In order to change the bins, we move the mouse along the horizontal axis and we double-click. Then we select the tab Binning and we go into the section Interval Definition. The number of intervals suggested by Minitab is 10, and we can see that the midpoint related to these 10 intervals are displayed here. However, even if the chart is showing effectively 10 number of intervals, only some bars are showing the related midpoint. If we want to show the midpoint under each bar, we need to customize the histogram. We click on the tab Scale, Position of Ticks, but instead of entering manually the numbers, we can copy and paste the data from the tab Binning. So if we go into Binning, we click on Midpoint Cut Point Positions, we copy the midpoints, we go into the tab Scale, and we paste them into this box. When we click OK, we can see that they all appear into the histogram. Now, if we want to change the number of intervals, we double-click on the x-axis, we go into Binning, and instead of an interval of 10, we can choose, for example, an interval of 20. When we click OK, we can see that we have customized the histogram. Once again, if we want to show the midpoint under each bar, we know that we need to double-click on the x-axis, we go into Binning, we click on midpoint, we select all of them, copy, we go into the tab Scale, and we paste them. We click OK, and now they all appear under the chart. Let's open again the dialog box. We're going to binning. Another way to define the interval is to type them into this box, but it's not always practical to type all the numbers. So an easy way to do it is just to consider the range that we have into the dataset. So let's suppose that the range of my dataset is 5 to 50. So the smallest value is 5 and the biggest value is 50. Then I just type slash and I enter the size of the interval that I want to have between each unit. So let's suppose that the first bar will have a midpoint of 5 and the second bar will have a midpoint of 10 and the third bar will have a midpoint of 15. So the size of the interval between each unit will be 5. I tap 5, I copy this value into the tab Scale within the box position of the ticks. When I paste the values and I click OK, then we can see that they appear into the chart. If I want to decrease the size between the different bins, I double click, I go into the tab Binning, and then the smallest value is 5, the biggest value is 50, slash, if I want only friends of 2 units, I tap 2, I copy the values, I go into the tab Scale, and I paste them into the box. When I click OK, then we can see that we have customized the histogram. So we can clearly see that the data is not symmetric, it's skewed to the right, showing a large number of occurrences in the lower values. The second description of the histogram is the central tendency. We can approximate this value by looking at the histogram, but this will be a guess. Usually we are interested in the centering because we want to know where we are in regards to the process performance. We want to see how the data performs to the specifications. For ease of interpretation, we can add a reference line to see clearly on the graph the portion of data that falls outside the specification limit. Suppose that the process should perform within the range of 0 to 15 working days. Let's add this reference line. So we right-click, we go into Add Reference Lines, we enter 15, in the box Show Reference Lines at Data Values. When we click OK, then we can see that the reference line is appearing into the chart, showing the portion of data that is outside this reference line. If we want to have an accurate description of the center of the data, we can use the command start basic statistics display descriptive statistics, and then we select the column, the variable, and we click on statistics. Let's bring all of them to none. The 3 statistics to use to describe the center of the data are mean, median, and mode. So we click on mean, median, and mode. When we click OK, then we click OK again, we can see that in the session window we have the mean, the median, and the mode for this histogram. The mean is the arithmetic average we usually use when we take the sum of all the data points and we divide them by the number of data points. The median is the middle value in the data, while the mode is the most frequently occurring value in the data. The more common used are the mean and the median, and the choice of using the mean or the median is driven by the shape of the data. The mean is influenced by extreme values. This explains why the mean is greater than the median in our example. Looking at the data, we can see that there is an outlier. So the recommendation is to assess the shape of the data before deciding which average to use. So far, we have seen that the first step is to analyze the shape of the distribution, and the second step is to determine the centering of the data. The third step is to describe the variation or spread of the data. The spread shows how data tends to spread out from the center. There are three measures of spread. There is the range, which is the difference between the largest and the smallest values in the dataset. The variance, which shows how far each data point is from the mean, and the standard deviation. If you want to make them appear in the session window, we go into Start, Basic Statistic, Display Descriptive Statistics. We have already the values that have been selected. We go into Statistics, and this time we select Variance, Range, and Standard Deviation. OK, we click OK, and then we can see that we have the mean, the standard deviation of mean, the variance, the median, the range, the mode.